Welcome to our mathematics class, and today we are going to look at ordering positive and negative fractions. In our previous class, just to remind ourselves, we were actually looking at a situation where we can have fractions that is mixed fractions and improper fraction, and see how to convert maybe from mixed numeral to improper fraction and from improper fraction to mixed numeral. We realized that just to look at a number like 2 and 2 over 3, this is a mixed numeral, which implies that it has got two parts. One part here where we have the whole number, and the next part here where we have a proper fraction. So we normally have two areas, that is a whole number and a proper fraction. So the two of them here makes what we call a mixed numeral. And this can be converted into the other. And to look at the conversion, if we want to convert the mixed numeral into a proper fraction, so we convert by doing the following. We simply look at the whole number that we have. We look at the fraction, the proper fraction that we have, so that we can get to know how do we arrive at that. So the first method, as we saw earlier on, this one simply means 1 plus 1 plus 2 over 3. So which means that when we have a 1 is the same as 3 over 3, another 1 is the same as 3 over 3, and then plus 2 over 3. You will find that this will give us the denominator remains as our 3, and then up where the numerators is 3 plus 3, which is 6, and then plus 2, which is 8. So in our conversion, we find that we can convert improper mixed numeral into improper fraction by using the method we have. Alternatively, if you don't want to use this method, we can also convert as follows. Given that the number we want to convert is 2 and 2/3, then for our conversion here, we shall take the denominator, which is 3, multiplied by the whole number, and add the numeral. So I'm saying for us to convert this using second method, take the denominator of the proper fraction, multiply by the whole number, add the numerator. So denominator is 3 multiplied by the whole number, which is 2, and then we add the numerator, which is 2. So you realize that to make up the numerator, it will be 3 times 2 plus 2. But the denominator remains as 3. This one gives us 6 plus 2 over 3, which is 8 over 3. So this is the second method. If you don't want to use this, you can simply use the second method to find or change our mixed numeral into the improper fraction. Let us look at one more exercise on converting the same. So take, for example, 2 and 3 over 4. 2 and 3 over 4. So convert into improper fraction. Convert 2 and 3 over 4 into improper fraction. We shall start looking at it from method 1, where our method 1 will mean we have two whole numbers. From the denominator of 4, then it implies that given that we have 3 over 4, then we find that 1 is the same as 4 over 4. Therefore, 2 is the same as 4 over 4 plus 4 over 4. And 2 and 3 over 4 will be the same as 4 over 4 plus 4 over 4 plus 3 over 4. The denominator is the same, so it remains 4. 4 plus 4 is 8. 8 plus 3 is 11. So we have been able to convert 2 and 3/4 into improper fraction of 11 over 4. Supposing we used the second method. We want to convert 2 and 3 over 4 into improper. Then this one is straightforward. This is the denominator, this is the whole number, and this is the numerator. And as we saw earlier on, we take the denominator, which is 4, multiplied by the whole number, which is 2, add the numerator. So we shall have denominator 4 multiplied by the whole number, then add the results that you get to 3. The denominator is maintained as our 4. So 4 times 2 is 8 plus 3 and then over 4. This one gives us 11 over 4. Realize that the two methods gives us the same answer. We should also be able to convert the same backwards, that is from improper fraction to mixed numeral. Let us look at that. So convert 11 over 4 into mixed numeral. Now, as we saw earlier on, we find that for us to get an improper fraction, we need to have converted a mixed numeral. This time we want to use a mixed numeral, improper fraction to go and get a complete mixed numeral. Now, for us here, the denominator we have is 4. And we want to convert this. You realize that 11 is not a multiple of 4, but there is a number that is a multiple of 4 within 11. One of it is 4, and another one is 8. So the highest that we have is 8. So we are going to break this to one numeral which has a multiple, and another, the remainder remains as a fraction. So one of the numeral which is a multiple here is 8, and what remains is 3. So you realize that 8 plus 3 is 11, but because we are breaking 8 over 4 and 3 over 4, you'll notice that 8 divided by 4, it is divided evenly without the remainder, which implies that 8 is a multiple of 4, but this other part where we have 3 over 4, this one remains a proper fraction. So when you divide 8 by 4, you'll get 2 plus 3 over 4, which will give us 2 and 3 over 4. And that is our answer, and it is written in a mixed numeral form. Now, if we don't want to use that particular method, then we can opt for method 2. And in method 2, it is very simple. Just take it easily that 11 over 4 is the same as 11 divided by 4. Or you can simply be saying 11 divided by 4. You'll find that when you divide this, 11 divided by 4 will give us 2 remainder of 3. 11 divided by 4 is 2 remainder 3. So if that is the case, what we are remaining with here is 3 of divided by 4, which is not divisible. You cannot divide it evenly, so we leave it like that. So the 2, we shall find that we have our 2. The remainder, what is remaining is 3 divided by 4. So in this particular case, when you write a fraction, 11 over 4 is simply the same as saying 11 divided by 4, which can be written this way, or you can have it as 11 divided by 4, which gives us 2. And when you have 2, as I was saying, remainder 8 because remainder 3 because 2 times 4 is 8, and when you subtract, you remain with 3. That's why I have 3 remainder there as a remainder there, because it is not divisible by 4. So this remainder that remains is what forms the proper fraction that we have here, while the 2 we have here forms the whole number part of our mixed numeral. So that is how we can simply convert proper fraction, an improper fraction, into a mixed numeral. Now let us now look at ordering positive and negative fractions. As earlier on we've been able to look at a set of whole numbers, and from a set of whole numbers we can simply rearrange them either in ascending manner or in a descending manner. Take for example, this is the set of the following. From the following set of all numbers 3, 7, 15, 6 and 2, arrange them in A, ascending order, and B, descending order. Now for whole numbers, it's just a number on its own. It is very simplified. We can simply get to know the value of the number. And when we say ascending order, we only we are required to start from the least value and finish with the largest value. From this particular case, 2 becomes our first digit. This is our second one. This is our third, the fourth, and the fifth. So we already have the same, and we can bring them here. The order will be 2, then we have 3, then we have 6, then we have 7, then we have 15. So we have been able to arrange a set of all numbers in an ascending order. So if it is the descending order, it's just the reverse of the ascending order. So I'll expect you to have 15, 7, 6, 3, and 2. So it is simply the reverse of the ascending order. This is when we are looking at whole numbers. Whole numbers are simply handled easily. You can easily order them. But this time round, we want to look at fractions and see how we can simply come up with ordering a set of fractions. Let us consider this fraction I want us to consider this fraction 3 over 4 and 1 over 2. Now, before we choose the order, we need to know between 3 over 4 and 1 over 2, which one is larger than another one, or which one is greater than another one. From this, you'll realize that 3 over 4 is greater than a half, and the reason is because when we bring in the number line, 3 over 4 lies on extreme right of a half. I'll demonstrate it with the number line as we have always seen earlier. So in our number line here, we have a number line starting from 0 to 1, but it is divided into 4 parts, which implies that the first part that we have is a quarter, which is 1 over 4. The second part is 2 over 4, which is our a half. The third part is 3 over 4. This is 1, which is equivalent to 4 over 4. This is the fifth part, which is 5 over 4. Or as a mixed numeral, 1 and a quarter. This is 6 over 4, which is the same as 3 over 2, or 1 and a half. Now, we wanted to show from the number line that 3 over 4 is greater than a half. And I'm saying from the way we saw it earlier on about the number line, we realize that in the number line, when a number is on the extreme right, then that number is greater than the one which is on the left. So let us see. Our half is here, and our 3 over 4 is on the right. So the fact that it is on the right automatically tells us that it is greater than a half. And that is why we have the side here that 3 over 4 is greater than a half. You look at the denominators, they do not tell us anything, but the weight it carries is we need to find now the right way of how do we identify that this is the case. If we did want to use this, how else could we have arranged this or confirmed that 3/4 and a half here it is that 3/4 is greater than a half? We shall find what we call the LCD, that is the lowest common denominator for the two by considering the 4 and the 2. You will find that for this particular case, the lowest common denominator for this is a 4. Then 4 divided by 4 is 1. 1 times 3 is 3. So we have the first part as 3/4. And then 4 divided by 2 is 2. 2 times 1 is 2. So we have 2/4. Now we have the denominator as the same. We look at the values between 2 and 3. Which one is greater? Definitely 3 is greater than 2. So you'll find that the sign that shows greater than is best placed to prove that the statement that we have here is mathematically correct. So let us note the following. Let us note the following in our notes. And those are the guidelines we are going to use as we carry out the order for the fractions of both positive and negative. 1, we find that to order or just to arrange Now, there are points that we should note. I'll go as we break. We are saying to order or arrange positive fractions, we must know how to compare different fractions. This is often done by considering equivalent fraction. Just as we saw earlier on in our previous example, where we had 3/4 and a half. For us to order this, the two that we have, we first need to actually compare the two fractions, and to compare the two fractions, we shall need to use the principle of equivalent fractions, where we said we shall consider the lowest common multiple for the 4 and 2, which is 4, and then you'll realize that 4 and 3 and 4 and 4 will give us 3 over 4, and 4 and 2 will give us 2 times 1, which is 2 over 4. Now, from this, we are able to identify which one is smaller and which one is greater. If this is the case, then we find that we are able to simply notice which one is greater. 3 over 4 is greater, and 2 over 4, which is a half, is less than the other one. So we can easily rearrange and order them. Basing on this, I want us to say something about the denominator. Before we start, when we have the denominator, we should say this. There's a point we should note from this. We have the common denominator here, but the numerator is speaking different. We say that if the denominators are the same, then the number with the least numerator becomes the smallest, while the one with the highest numerator becomes the largest. Let us look at that point and put it down. If the denominator is the same, the smallest if we have the same denominator as we saw earlier on, 3 over 4 and 2 over 4, then the smallest fraction is the one with the smallest numerator. For this case, the one with the smallest numerator is 2 over 4. So this one is smaller than this. So you can simply say that 3 over 4 is greater than 2 over 4. But 2 over 4 was representing what? A half. So 3 over 4 is greater than a half. We first made them equivalent, and then we looked at the behavior of the denominators, and we are told by this point that if the denominators are the same, then the smallest fraction is one with the smallest numerator. Now, for this other point, they are saying if the numerators are the same, then the smallest fraction is one with the biggest denominator. And why do we say that? Is because of what I'm going to show here. Let us take any number. Let us take 2 over 3, and we take 2 over 5. 2 over 3 and 2 over 5. From the principle we have here to note, it is that the smallest fraction is the one with the biggest denominator. So biggest denominator is 5. 3 is smaller than 5. However, because the numerator is the same, then the fraction with the biggest denominator is the smallest, which means that these two has been divided into many parts, so as many as 5 parts, while 2 other side has only been divided into 3 parts. So in this particular case, it means 2 over 3 is greater than 2 over 5. Now, to order 2 or different denominators here, we can use the knowledge of equivalent fractions, as we said earlier on. But in this particular case, we are looking at the denominator. Therefore, the knowledge of considering what we said earlier on, lowest common denominator, comes in. So if we are looking at fractions which are different, 2 different fractions, then the knowledge of lowest common denominator will come in. And let us look at that and see. if we have a number like, we want to compare a half and a seventh, which is 1/7. We are saying that these are two fractions. The two fractions have got different denominators, but we are supposed to order them, to arrange them, or to know which one is small and which one is large. So this particular case here, we shall consider the idea of lowest common denominator, which means we shall find the lowest common denominator for 2 and 7, and you'll all notice that it will give us 14. So we have 14 in both cases. What we need to determine is what's up there. 14 divided by 2 is 7. 7 times 1 is 7 there. And then 14 divided by 7 is 2. 2 times 1 is 2. Now we've been able to reduce all of them to have the common denominator. Then we can now compare the numerators. And in this case, from the principle we had, we said if the denominator is the same, then the numerator with the least value is the smallest. In this particular case, this is smaller, so 7/14 is greater than 2/14. But this is not the initial fraction that we have. So we replace this equivalent fraction with the original fraction that we had. So we realize that 7/14 was our half and 2/14 was 1/7. Therefore, we can simply come and say 1/2 is greater than 1/7. Take note that we've said we have got an ascending order. And this one is when numbers are ordered going up. That is to say, that is smallest to largest. From smallest to largest. While if we are asked to arrange in a descending order, is when are ordered going down. That is to say, from largest to smallest. So the order of arranging is always two. Either we order the fraction in ascending order, or we order fraction in descending order. If it is ascending order, is when numbers are ordered going up, that is from smallest to largest, while descending order is when numbers are ordered going down, that is from largest to small. So let us look at questions touching on various areas, starting by first question that will touch on comparing fractions as we move on. Place the correct mathematical symbol . Place the correct mathematical symbol greater than, equals to, or less than in between the following pairs of fractions to make true mathematical statement. And the part 1 of that is 2 over 5, 3 over 5. Part B, 1 over 3, 1 over 5. Part C, 2 over 3, and 3 over 5. Part D, 2 and 3 over 7, and 16 over 7. And finally, number E, we have negative 1 over 3 and negative 2 over 3. So we are supposed to place the correct sign in between these pairs of fractions so that you can make a correct, true mathematical statement. And you shall always give reasons as to why it is the way it is. Let us start with the first one. So we are looking at the solution for this. So this is not complicated. We are going to refer to the statement, general statement that we were given. Why? Because we have the denominators being the same, all of them are 5. And the rule says that if the denominators are the same, then the numerator with the least value is the smallest. If the denominators are the same, the numerator with the least value is the smallest. So we have 2 over 5 and 3 over 5. From this, the denominator is the same, but the first one has the least value compared to the second one. Therefore, the one with the least value is the smallest. So this one is less than. This sign means less than. 2 over 5 is less than 3 over 5. Why? Because the denominators are the same, but the numerator, the first one has the least value of the numerator compared to the second. Second question, it was (1 over 3) and 1 over 5. Now for this again, we had the third point rule, which was saying that the rule was saying that if the numerators are the same, then the denominator with the greatest value or the highest value is the smallest. The numerator are all 1. But look at this. When 1 is divided into 3 pieces and 1 is divided into 5 pieces, which one is smaller? You will find that definitely 1 which you divide by 5 becomes the smallest. So if this is smaller, I'll expect our sign now to say that a third is simply greater than a fifth. This can also be shown when we go to the number line. We have 2 number lines here. One, we shall divide it into 5 parts. Another one is into 3 parts. So we have the first part. This is a fifth. 2 over 5, 3 over 5, 4 over 5, and 5 over 5, which means 1. For this one is 1 over 3, this one is 2 over 3, and this one is 3 over 3, which is 1. Just from our number line, consider the space for a fifth and the space for a third. Definitely a space, not from 1, 0 to 1 is the same, but from the first space, a third is wider than a fifth. So the number line can also tell us that a third is greater than a fifth. The next was C was 2 over 3 and 3 over 5. Now for this case, the two fractions are completely different. The numerators are not the same. The denominators are not the same. Then the question that comes in, how do we approach this? So first, for this particular case in our solution, we need to find the LCD of 3 and 5. That is the lowest common denominator of 3 and 5, and you'll find that it is 15. So the lowest common denominator of 3 and 5 is 15. So from the 15 that we have, I want us to produce equivalent fractions of the 2 here. So 15 divided by 3, because the denominator now, the lowest common denominator is 15, so we have 15 here. So 15 by 3 is 5, 5 times 2 is 10, while the second one is 15 by 5, divided by 5 is 3, 3 times 3 is 9. So we are having two of them. That is 10 over 15 and 9 over 15. The denominator is the same now because they are equivalent fractions. The numerators are not the same. The rule says if the denominator are the same, then the numerator with the least value is the smallest. Between 10 and 9, 9 is the least, so means that 10 is greater than this. So this one here, we are only coming up with what we call equivalent fractions. Now, when we're having noticed this, we don't leave the answer here because none of these two equivalent fractions are either 2 over 3 or 3 over 5. Therefore, we shall be required to rewrite the answer in original format. And the original format of this is now the same. So 10 over 15 is greater. So we are coming to say, therefore, 2 over 3 is greater than 3 over 5. The next one was requiring us to again do the same, but in a different format. The fourth one was 2 and 3 over 7 compared to 16 over 7. 2 and 3 over 7. So this is a mixed numeral, while the second part here is an improper fraction. So if this is the case, then in our solution, you see, we cannot straightforward compare and we find what we require. We need to change everything to look the same. So we shall need to convert 2 and 3 over 7 as an improper fraction, and then we can be able to compare the two. For this particular case, to convert it using any of the methods, we find that we shall have 2 times 7, which gives us 14, plus 3, which gives us 17. So the first one is the same as 17 over 7, and this one is already improper, which is 16 over 7. Then we ask ourselves, between 17 over 7 and 16 over 7, which one is greater than the other one or smaller than the other one? This, because the denominator is now the same, it is 7, then we consider the numerator. One with the highest is the greatest. So 17 and 16 means 17 is greater. So the sign that comes there is that sign. But we don't maintain this. We rewrite the original question. Therefore, we shall say that therefore 2 and 3 over 7 is greater than 16 over 7. So we are able to get the equivalent fraction first and then get into this. For the last question, this one had signs, negatives and positives, and in this particular case here, we were to give the correct mathematical statement between negative a third and negative 2/3. Negative a third and negative 2/3. For this particular case, there are 2 ways you can get this, just from the number line again. So we shall use the number line. And as from the number line, we say extreme right is larger than a number on the extreme left. 1 unit is divided into 3. So we have our number line here. From our number line, we identify the regions that have a third, and a third is here. And then we have negative 2/3, which is here. So from the number line, we say if your number is on the right side of a number, then it's large. So a third is on the right side of negative a third is on the right side of negative 2/3. So which implies that negative a third is greater than negative 2/3. That is how we work out when using the number line. Still on the same, if we don't want to use this, we shall first be required for the same, because if we don't want to use all that, we look at the denominator because it is the same for the denominator. So we shall not bother about the denominator, but instead consider the numerator. And the numerator here is -1 and -2. When you come to -1 and -2, again, you refer to the number line. You realize that from 0 to -1 is actually on the right hand side of -2. -2 is further. That's why you find that negative 2 is on the left-hand side of the negative 1. So any number that is on the right of a number is simply larger. So if we had a number line like this, and we are considering just numbers, that is 0, minus 1, minus 2, you realize that minus 1 comes first. So minus 1 is larger than minus 2, but the denominators are the same. So from this, we just notice that where we have minus 1 will be greater than where we have minus 2. So you can simply use that, and it will still give us the same answer. In our next class, we are now going to start the ordering of the fractions, and then we'll go into the decimals. So in our next class, we shall look at the order of fractions. Where now, in this particular case, we shall have a group of fractions brought together, and then we look at those fractions, we make them equivalent, and we start rearranging them. That is what we shall be looking at when we come to the next class, and also the decimals. Thank you for the day.